Hey guys, welcome to lecture series on Z transform. For more videos, go and check in my I button over here. So you will get my complete lecture series. As well, you can check in my description box also. So you will get the complete lecture series on Fourier transform. As well, first unit for linear differential equation with a constant coefficient. Then after Fourier transform, Fourier sine, cosine, their inverse transform, Z transform. And we are going to end our today's lecture. It is a Z transform. Okay, so I already uploaded plenty of the videos, guys. If you are interested to see, go and check in my playlist. So in my today's video, I'm gonna explain to you all multiplication property. Okay, for our Z transform. Like, what is multiplication property? So we multiply some k to the z. Actually, k terms matter over under z transform, because we run k from minus infinity to plus infinity in a z transform. So k terms matter over here. So for that, we are going to multiply k to our function, and we derive our property here. Okay, let's get dive into our today's lecture. First of all, I'm going to explain to you all the property, and then we go for some of the examples. So here I have added one property that if z transform of f of k, it can be written as f of z. Okay, that means this one is the z transform for sequence of k. Okay, so it can be written as f of z. Then we write z transform of k. This k we are going to introduce here. Okay, that k multiplied by f of k. Okay, k multiplied by f of k can be written as minus z and derivative of f of z with respect to z. Okay, it is way easier and important property, guys. Okay, don't have anything inside here, just need to remember. So whenever we have k multiplicand to the f of k, okay, k matters with f of k. Okay, because we running our sequence from minus infinity to plus infinity. So k coming here with the f of k, then we write minus z into derivative of f of z with respect to z. Okay, yes, that is only the property. So we go for solving some of the example based on this property. So here we can see that I added one example, z transform of k square f of k. So we want the z transform of k square f of k. Okay, now see that, compare this term here with this one. Okay, so we have to compare both of the term together. Now see that whenever we have single time multiplied by f of k, that time we take a single derivative. Okay, and multiply minus z single times. But whenever you have k square, that means if you multiply k two times, then that means you have to take double differentiation of a dz and two times multiplication of a z here. Okay, yes. So minus z we go for multiplying two times. Let me write the solution for this. It's way easier, guys. Don't have anything. Okay, so we write a z transform of k square f of k. Z transform of k square f of k, it can be written as, now see that how can we write this one. So it is a two times na k, it is multiplied two times, so you have to multiply minus z two times. Okay, so minus z means minus z into minus z. Okay, so obviously it is a minus times z square. Okay, minus z into minus z, I multiply minus z two times, and differentiation also two times. So double derivative, we write d square by dz square. Okay, we write d square by dz square f of z. This one is our z required z transform. Now see that, guys, we got the solution in one step only. Okay, I don't have anything, just need to understand whenever k go for two times or three times, that means you have to replace the identity like this. Okay, so how can I write this one? You can simplify in further step also. So we write this one as minus z into minus z, that means minus z two times. Okay, minus z square d square by dz square f of z. Okay, this one is actually expansion for solution for our z transform. Okay, see that I applied here multiplication property for this example. It's way easier to understand. Okay, yes, so we go for more examples. So here I added one more example, k into 5 raised to k. Okay, this one is the 5 raised to k over here, and k greater equal 0. So we are going to apply this property, okay, this property for solving this one. And now see that we can observe here minus z into dy dz of f of z, that one. Okay, so we want the differentiation of f of z later on. Okay, yes. So k we go for the applying this property now. Okay, k into 5 raised to k when k greater equal 0. Yes, now see that let me apply the property z transform of k into 5 raised to k. Z transform of k into 5 raised to k. Okay, k into 5 raised to k. Okay, it can be written as, now see that, compare here, k into 5 raised to k, f of k is a 5 raised to k as it is here. So my apply the here minus z. Okay, and f of z, what we have here, f of k is a 5 raised to k. So but we want the f of z. Okay, so what is this f of z? F of z is the z transform of f of k. Okay, f of z, it is the z transform of f of k. Now see that z transform of f of k can be written as f of z. So we have the value for f of k is a 5 raised to k. Okay, and we want the d by dz of f of z. Okay, okay, and f of z, we know that what is the f of z? F of z is the z transform of f of k. Okay, f of k, and what is the value for f of k is a 5 raised to k, z transform of f of k. Okay, this one is the z transform of f of z is the z transform of f of k. This is the actual representation. We represent z transform of f of k as f of z. Now you can see that here, f of z as a z transform of f of k. Okay, so we want the f of z here for the derivative. Okay, so for f of z you have to find out the z transform of f of k, and we can see that f of k we have here k into f of k, that means k into f of k, it is a 5 raised to k. Okay, so we have f of k is equal to 5 raised to k. Okay, and we want the z transform of f of k, that means z transform of 5 raised to k. Okay, so what is the z transform of 5 raised to k? And we have condition of k, which is k greater equal 0. So we take k greater equal 0. Okay, we want the z transform of 5 raised to k when k greater equal 0. So we know that z transform of a raised to k when k greater equal 0, we write z upon a minus z. Z upon z minus a, sorry. We write this one as a z upon z minus a. Okay, this one we write z upon z minus a, and modulus of z, which is bigger than modulus of a. Okay, this condition hold here. Okay, so we are going to apply this condition for solving next steps. Okay, z upon z minus a, what is the value for a? A raised to k means 5 raised to k, it is going to be a 5. Okay, so we write z upon z minus 5. Okay, we write z upon z minus 5, and modulus of z greater than modulus of 5. Okay, modulus of z greater than modulus of 5. So this one is the actually z transform of 5 raised to k. So we want the z transform of 5 raised to k as a f of z. Okay, this one is the z transform of 5 raised to k. So we write this one as a f of z also. Okay, this one is the value for f of z into 5 raised to k. Okay, so I got the f of z as a z upon z minus 5. Replace this f of z here. Okay, so I'm going to write this one as minus z into f of z as a z upon z minus 5, z upon z minus 5. Okay, and completely we want the derivative for this d by dz. Okay, so we want the d by dz for this bracket. Okay, so under this bracket we have d by z dz of this thing. Okay, so we want the derivative of z upon z minus 5 with respect to dz. Now see that as it is the form of u upon v. Okay, so you can apply directly quotient rule for the derivative, and it says that d by dx of u upon v into derivative of u minus u into derivative of v upon v square. Okay, So that one is the derivative d by dx of u upon phi. Okay, this is the rule we are going to apply here for finding z upon z minus 5. Minus z, it is outside of this derivative, guys. Okay, minus z, it is outside of this derivative, but under derivative we have this term. Okay, so now see that how can I go for writing, how can I write this part. Okay, let me take to the next page. Okay, I will explain here with the next page. Okay, yes, so we have the differentiation of minus, let me write the next step, minus z. Okay, minus z outside here. Okay, so we want the d by dz of z upon z minus 5, d by dz upon of z upon z minus 5. Okay, this one is the derivative we want for our next step. Okay, minus z keep as it is. Okay, u upon v. Okay, that means phi z minus 5 v as it is, derivative of u. Okay, derivative of u means derivative of z with respect to z. Okay, which is gives us the value 1, no need to write, minus u z as it is, and the derivative of v z minus 5 with respect to z differentiation, it also gives us the value 1. Okay, no need to write, completely divided by v square, that means z minus 5 bracket square, bracket complete. Okay, yes, so what we do, that plus z and minus z can be cancelled, so we write minus minus plus. Okay, minus z into minus 5, it is a 5 times z only. Okay, minus minus gives us the value plus 5z upon z minus 5 bracket square. Okay, 5z upon z minus 5 bracket square. This one is our required z transform of z into k raised to 5. Okay, this one is a required z transform of z transform k 5 raised to k when k greater equals 0. Okay, I hope you all have understood this solution, guys. It's way easier, don't have anything. So even after, if you found anything difficult, guys, let me know in my comment section. I will come up with the similar videos. So thank you everyone, thank you for my today's lecture.